What if I told you that spiders can change their web-making behavior in space? Picture this: a universe where even the smallest creatures adapt to the mysteries of microgravity. Intrigued? Then stay tuned as we delve into the top 10 space experiments aboard the International Space Station. Gravity, our constant companion on Earth, but what happens when it's no longer there? It's an intriguing question, isn't it? On Earth, we're so used to gravity keeping us grounded that we hardly ever think about it. But when astronauts step into the International Space Station, they enter a world where gravity is practically non-existent. This state is known as microgravity. Microgravity isn't just about floating objects or astronauts somersaulting in space, though. It's a unique environment that allows us to study the fundamental laws of nature from a new perspective. It's like peeling back the layers of an onion, revealing the core of how things work. For instance, without gravity, how does a flame behave? Or how does water move? These are just some of the questions that scientists are trying to answer by conducting experiments in microgravity aboard the International Space Station. But why is studying microgravity so important? Well, the answers we find could have profound implications. They could help us understand more about our own planet, improve technologies, and even guide future space missions. The types of experiments conducted to study these effects range from biology to physics, from human health to advanced materials. Each experiment shedding light on how the absence of gravity affects different aspects of life and matter. Without gravity, things get much more interesting and complex. The human body is an amazing machine, but how does it function in space? When we venture into the cosmos, we carry with us the most intricate and delicate of systems, the human body. Astronauts aboard the International Space Station are not only space explorers, but also subjects of extensive scientific research. The microgravity environment of the ISS is a unique laboratory for studying the effects of weightlessness on human biology. One of the most crucial areas of study involves changes in bone density. In the absence of gravity, our bones, which are designed to bear weight and facilitate movement, start to lose their density. It's estimated that astronauts can lose up to 1 to 2% of their bone mass per month in space. This is similar to the rate of bone loss in individuals suffering from osteoporosis on Earth. Muscle mass is another area significantly affected by microgravity. Without the need to fight against gravity, muscles can atrophy and weaken. Interestingly, even the heart, a muscle that works tirelessly from the moment we're born, can change shape and become more spherical in space. But it's not all doom and gloom. The human body is highly adaptable, and astronauts undergo rigorous exercise regimes to counteract these effects. On the ISS, astronauts spend around 2 hours a day exercising, using specially designed equipment that allows them to lift weights and run in a weightless environment. Space is also a fantastic place to study the human immune system. Some studies have shown that the immune system doesn't function as effectively in space. This has significant implications for long-term space travel and colonization. These are just a few examples of the incredible research conducted aboard the ISS. The findings not only help us prepare for a future where humans might live and work in space for extended periods, but they also have potential applications for treating diseases and conditions on Earth. As it turns out, our bodies adapt in surprising ways to life among the stars. Space isn't just a place for astronauts, it's also a testing ground for new materials. The International Space Station, or ISS, serves as a unique laboratory where scientists push the boundaries of knowledge and innovation. Have you ever wondered how materials behave beyond the confines of our planet? You see, in the microgravity environment of space, materials react differently than they do here on Earth. The absence of gravitational pull allows us to explore properties and reactions that we simply can't replicate on our home turf. Let's consider an experiment with metals. In space, metals can be combined in ways that are impossible on Earth due to the absence of gravity. This has led to the creation of new metal alloys with potential uses in various industries, from automotive to aerospace and beyond. Or think about experiments with extreme temperatures. The ISS orbits Earth in a vacuum, which can be both incredibly hot and unimaginably cold. This allows scientists to test how materials withstand these harsh conditions, providing valuable insights for the development of future spacecraft. And then there's the fascinating world of nanomaterials. These tiny structures, often just a few atoms thick, exhibit unique properties in a microgravity environment. Understanding these could revolutionize technology, from super-efficient solar cells to ultra-fast computers. These experiments aren't just for the sake of science, they're paving the way for future space missions. Indeed, by understanding how different materials behave and interact in space, we're building the stepping stones to the stars. The knowledge gained will help us design and create the next generation of spacecraft, leading us further into the cosmic unknown. Physics on Earth is one thing, but physics in space? That's a whole different ballgame. Physics, as we understand it on Earth, is based on laws and principles observed in our terrestrial environment. However, when scientists venture into the cosmos, they encounter environments that challenge our understanding of these laws. The International Space Station, or the ISS, has been a hub for such groundbreaking physics experiments. One of the most intriguing experiments aboard the ISS is the Alpha Magnetic Spectrometer, or AMS. This sophisticated particle physics detector is designed to study cosmic rays, an essential step in the quest to understand dark matter. Dark matter, a mysterious substance that makes up about a quarter of our universe, remains elusive, but the AMS has detected signals that could be related to it. Then there's the Cold Atom Lab, where scientists create what they call a fifth state of matter, known as Bose-Einstein condensates. In this state, atoms are supercooled to almost absolute zero, causing them to move extremely slowly and behave like waves rather than particles. This allows scientists to study quantum phenomena, which are ordinarily too small to observe. Another fascinating experiment is the study of gravitational waves. These ripples in the fabric of space-time, first predicted by Albert Einstein, were confirmed by the LIGO experiment on Earth. But in space, we can detect lower-frequency gravitational waves that are out of reach for terrestrial detectors. This could open up a new window into the universe, allowing us to observe events like the merging of supermassive black holes. All these experiments and more are reshaping our understanding of physics, challenging what we thought we knew and opening up new frontiers of knowledge. It's a testament to human curiosity and our relentless pursuit of understanding the universe we inhabit. These experiments are reshaping our understanding of the universe. Remember the spiderweb teaser from the start? Here's the full story. In the wondrous expanse of the cosmos, even the humble spider takes on an extraordinary role. This is the tale of the spiderweb experiment aboard the International Space Station. In the early 2000s, NASA scientists decided to test how spiders would adapt to life in microgravity. They sent 2 orb-weaving spiders, often found in our backyards, to the ISS. The question was simple. Could these creatures of Earth weave their intricate webs in the absence of gravity? The experiment was part of a broader study on how different organisms adapt to life in space. You see, spiders rely on gravity to build their webs. They drop a line of silk and let it fall, using the tension created by gravity to construct their geometric masterpiece. But in space, there's no falling. So how would our 8-legged friends adjust? The results were surprising, to say the least. Initially, the spiders struggled. Their first webs were, well, a bit of a mess. But then, something remarkable happened. The spiders adapted. They started building more symmetrical webs, using their bodies to create tension in the silk, effectively replacing the role of gravity. This discovery was more than just a fascinating glimpse into the resilience of life. It had profound implications. It told us that organisms can adapt to environments vastly different from those they evolved in. It gave us a new perspective on how life might exist elsewhere in the universe. In essence, the spiderweb experiment was not just about spiders, but about the incredible adaptability of life. It was about our quest to understand the universe and our place within it. It was a small step in our journey through the cosmos, reminding us that even in the face of the unfamiliar and the unknown, life finds a way. Just when you thought you knew spiders, space throws a curveball. We've looked at the past and present of space experiments, but what about the future? Imagine a future where experiments conducted in space could revolutionize our understanding of life, not just on Earth, but in the cosmos at large. That's exactly what the scientists and researchers aboard the International Space Station are striving for, with a slew of planned and proposed experiments that push the boundaries of human knowledge. One such future endeavor focuses on the study of dark matter, a mysterious substance that makes up about 85% of the universe. Researchers plan to deploy advanced detectors aboard the ISS to uncover the enigmatic properties of this unseen matter. Next, in the realm of biology, There are plans to study bioluminescent organisms in microgravity. The aim is to understand how these organisms, like certain types of jellyfish and fireflies, can generate light in the harsh conditions of space. This could lead to breakthroughs in energy production and even in medical treatments. Furthermore, in the quest to understand the effects of long-term space exposure on humans, scientists are planning to grow human organs in space. This could provide invaluable insights into human aging and disease, and may even aid in the development of novel therapeutic strategies. The potential impacts of these future experiments are mind-boggling. They could redefine our understanding of the universe, life on Earth, and even ourselves. As we continue to push the boundaries of the known, we inch closer to an era where truly, the stars are the limit when it comes to the future of space experimentation. Our journey through the top 10 space experiments aboard the International Space Station is coming to an end. It's been a fascinating ride, hasn't it? We've navigated through the mysterious realm of microgravity, explored the human body's resilience, and probed the properties of new materials, all without leaving the comfort of our earthly abode. These experiments, as varied as they are, share a common thread: the quest for knowledge, a deeper understanding of the universe we inhabit and our place within it. They've shown us that the human spirit, much like the universe, knows no bounds. We adapt, we innovate, we learn, and we grow, even in the most challenging of environments. Think about it. We've discovered how spiders weave their webs in zero gravity, a seemingly trivial experiment that could potentially revolutionize the way we build structures in space. We've tested materials that could shield future astronauts from harmful cosmic rays. We've studied how the human body changes in space, preparing us for longer voyages to Mars and beyond. But what does all this mean for us? These experiments are not just about pushing the boundaries of our knowledge. They're about paving the way for our future, expanding our horizons, and fulfilling our innate curiosity. They're about making the impossible possible. We're not just learning about life in space, we're learning about life itself, the universe, and everything in between. Each experiment brings us one step closer to answering the fundamental questions that have puzzled mankind for centuries. What's out there? Are we alone? As we continue to push the boundaries of our knowledge, who knows what we'll discover next? Until then, keep looking up. Before we wrap up, let's take a moment to reflect. Have you learned something new from our journey today? Did you find it as fascinating as we did? If so, we'd love to hear your thoughts. Please give this video a like and share your opinions in the comments section. Your feedback is invaluable to us, as it helps us create more engaging and informative content for you. And if you haven't done so already, don't forget to hit the subscribe button and the bell icon. This way, you'll be the first to know when we release new videos. Let's continue this journey of discovery together. After all, space is a vast and exciting frontier, and we're just getting started. So why not share this adventure with your friends and family? They might find it as intriguing as you did. Until next time, keep looking up. And remember, the universe is full of wonders waiting to be discovered.